So then we're going to look at the 802.15.5. Those are the wireless sensor networks, the mesh networks. So those are the air molecules on crack. That's what I like to call them, literally, because they are air molecules on crack. Those are the ones that we talk about that they become wearables when they anchor themselves onto your skin. So again, you have the ones inside of you, the 0.4 inside of you, then you have the 0.5 on the outside of you. Your human biofield is what transduces the electrical signal to let them do all of this. Wireless sensor networks, those are the ones floating around you, the geoengineered air molecules. They are more metallic. They get released with nanogels. They get macrogenomics with the laptop. They need to be able to use their remote to change the channels and settings of your ion channels inside your body. Now we're going to read on the official IEEE website. IEEE 802.15.5 WPAN Mesh Standard Low Rate Part, Meshing the Wireless Sensor Networks. This paper introduces a new IEEE standard, IEEE 802.15.5, which provides mesh capability for wireless personal area network devices. The standard provides an architectural framework enabling WPAN devices to promote interoperable, stable, and scalable wireless mesh topologies. It is composed of two parts, low-rate WPAN mesh and high-rate WPAN mesh. In this paper, we present only low-rate WPAN mesh because it is designed to support wireless sensor networks. IEEE 802.15.5 low-rate part is a lightweight scalable mesh routing protocol that caters well to the requirements of resource-constrained wireless sensor networks. By binding local addresses to the network topology, IEEE 802.15.5 obviates the need for route discovery. This eliminates the initial route discovery latency, saves storage space, and reduces the communication overhead and energy consumption. A distributed link state scheme is further built atop the block addressing scheme to improve the quality of routes, robustness, and load balancing. The routing scheme scales well with regard to various performance metrics. The standard also provides enhanced functions such as multicast, reliable broadcast, power saving, time synchronization, route tracing, and probability. We also present the performance evaluation of major functions performed with a 50 nodes tested deployed over a whole floor at Cunny Engineering Building. The results testify that the IEEE 802.15.5 will serve well for wireless personal area networks and wireless sensor networks. This was published on August 23, 2010. So it's already 14 years old. Now we're going to look at a PDF file from Tech Explorer. Wireless sensor networks have potential in healthcare and agriculture, says study. And as you can see here by the image, you have your personal area network, body area network, the gateway, application, GUI, and it's all connected to the internet. A new study published in the International Journal of Data Warehousing and Mining has found that personal health biomedical clothing based on wireless sensor networks has the potential to significantly enhance access to quality healthcare and boost food production through precision agriculture. The technology, which is part of the Internet of Things, enables the creation of more efficient healthcare and medical asset monitoring systems. The Internet of Things refers to the interconnected network of physical devices, vehicles, home appliances, and other items embedded with electronics, software, sensors, and network connectivity, which enables these objects to collect and exchange data. The Internet of Things allows for a seamless and automatic flow of data between devices, enabling a more connected and automated world. The study emphasizes the importance of having fast, reliable, and energy-efficient connection between wireless sensor networks. To achieve this, the control specifications, network layers, media access control, and physical layers must be optimized or co-designed. Researchers also highlight several challenges associated with the use of PHBC wireless sensor networks, including privacy, cybersecurity issues, an increased risk of malpractice lawsuits, and higher costs for both doctors and patients. The paper extensively discussed the potential risks of medical data eavesdropping, manipulation, fabrication of warnings, denial of services, and electromagnetic attacks. Electromagnetic because this is electromagnetic warfare. Now we're going to look at wireless sensor networks and applications. In this tutorial, we look at the wireless sensor networks. Wireless sensor networks are a group of specialized devices or sensors that we can use to monitor different environmental conditions and collect and organize that data at a certain central location. It detects and measures a number of physical conditions such as humidity, temperature, sound, pressure, speed, and direction, chemical concentrations, vibrations, pollutant levels, and many other such conditions. It has many applications and microcontroller projects. There are a number of nodes in a sensor network. These nodes are the detection stations, and they are very small and portable. There is a sensor, transducer, microcontroller, transceiver, and power source in every sensor node. The transducer senses the physical condition, and if there is any change, it generates electrical signals. These signals go to the microcomputer for processing. A central computer sends commands to the transceiver and transmits the data to that computer. So the BLE, your mesh networking potentials, work with the wireless sensor networks. This is your 802.15.5. You've got your user, sync node, and you see the sensors. They don't have to be equipment. They can be the air molecules. They can be inside of humans, outside of humans, on the skin of humans, and they create a peer-to-peer or point-to-point network. Here's the topology of the peer-to-peer or point-to-point network. They can do star, they can do tree, they can do mesh. Then you have your types of wireless sensor networks. You got terrestrial, underground, underwater, multimedia. These sensor networks can gather information in form of audio, video, and imaging. The sensor nodes in these networks connected with cameras and microphones. They can track and monitor different events occurring and keep a visual display of the events as well. For the purposes of data compression, retrieval, and correlation, these nodes also interconnect with one another through a wireless connection. Since audio and visual data transmit through these networks, they require high power consumption and bandwidth. Hence, they use advanced techniques of data processing and compression. For those who like to keep reading, I'm going to leave the links in the description.